Hello friends, today I am going to discuss about affine combination. Before that, I would like to first clear about what is linear combination of some vector. Suppose Rn is a vector space, then the linear combination of some vector v1, v2 up to vk is lambda 1 v1 plus lambda 2 v2 plus up to lambda k vk, where all these lambda I is coming from R. Right. So what is affine combination? Let v1 v2 up to vk are kth element in Rn. Then the affine combination of all these elements is lambda 1 v1 plus lambda 2 v2 plus up to lambda k vk, where all these lambda I is coming from R and sum of all lambda I is 1, where I is running from 1 to k. Here you will see that there is a main difference in between linear combination and affine combination is this one. That is, in case of linear combination, it is not necessary that all sum of all scalar is 1, but in case of affine combination, it should be, that is, sum of all scalar should be 1. Right. So let me give some example first. Suppose let's suppose v1 comma v2 in R square, then the affine combination of v1 v2 is lambda into v1 plus 1 minus lambda into v2, where all this lambda is coming from R. Right. So here if you add these two scalar, this is what, lambda plus 1 minus lambda is what, that is 1, which satisfy the affine combination. So this is a valid property. So my second example is, suppose 1 comma 1 and 2 comma 0 in R square belongs to R square. So the affine combination of these two elements, that is 1 comma 1 plus 1 minus lambda into 2 comma 0, right, where lambda is coming from R. Right. So if we see it geometrically, how it looks like, here 1 comma 1 is here and 2 comma 0 is here. So if you join this line, that is, if you put the value of lambda, that is which is coming from R, we get the straight line passing through 1 comma 1 and 2 comma 0. Right. So now I would like to give one more definition of affine span. Suppose affine span of this or some element, that is v1 v2 up to vk, equal to set of all possible affine combination of lambda I vi, where I is running from 1 to k, that is set of all possible set of all possible affine combination of vi, where lambda I is coming from R and sum of all lambda I should be 1. Right. So let's give some example. Suppose v1 comma v2 comma v3 belongs to Rq. Right. So what is the affine combination of these three elements? Suppose v1 is here and v2 is here and v3 is here, that is all. Here you see that all these 3 points are not in collinear. So therefore suppose v1 v2 and this one is v3, and if you take the affine combination of these 2 points, then we get the straight line passing through v1 v3 if we take the affine combination of b1 and b2, that is we get the straight line passing through b1 and b2. Similarly b2 b3 we get this type, right? That is, sorry, okay, this one, right? So, and if we take one more point here and one more point here, we get, and take the affine combination, we get the this line, and we take the point suppose here and here, we get the affine combination, that is this line. So if we continue this process, you get that is this type of line, that is we get the whole r square plane, right? So if these 3 points are collinear, are not in collinear, then the affine span of v1 comma v2 comma v3, that is r square, right? So suppose v1 v2 v3 are in collinear, right? So here suppose this point is v1 v2 v3, and we here take the affine combination of v1 v2 v3, we get the straight line passing through v1 v2 and v3.